Hello, welcome to Math Genius. In this video, we're going to look into a problem from binomial distribution. And this is the example of finding the smallest value of n. Let's have a look into this. So, factory makes water pistols, 8% of which do not work properly. A random sample of 19 water pistols is taken. Find the probability that at most 2 do not work properly. So if you remember, for binomial distribution, we need a number of trials and the probability of success. So if you look over here, so the probability of success is given to us and the number of trials are also fixed. So that's mean we know, and this is binomial distribution. So the number of trials are 19 and the probability of success is 0.08, which means probability of failure is 0.92. So probability of failure is 1 minus probability of success, which is 0.92. And then if we just recall the formula, if you remember, probability of x is equal to r. So this is NCR, p to the power of r and q to the power of n minus r. That's also, you remember, from binomial expansion. Okay, in the first part of it, it says find the probability that at most 2 do not work. So at most, so that's mean probability of x less than or equal to 2. So which means we need to look for the probability at x0, and we need to look probability at x1. We also need to look probability at x is equal to 2. So we simply use this formula over here, so which is 19 C0. So 0.08 times 0.92. So here this is r and this is n minus r, plus 19c1, 0.08, 0.92. So here probability of success is 1 and then to the power of 1, and probability of failure to the power of 19 minus 1, which is 18. So 19c2, 0.08 to the power of 2 times 0.92 to the power of 17. So if we use the calculator for this and we calculate this, so how much we will get? So we're able to find probability of x less than or equal to 2 is 0.809. Okay, now let's have a look into the second problem. So in a random sample of n water pistols, so the probability that at least one does not work properly is greater than 0.9. Let's get some space over here for the working out. Okay, in this one, it's the random sample is given, which is n over here. So that's mean x is binomially distributed with the number of trials n, and the probability is success is same 0.08. So now it says that the probability that at least one does not work properly. So the probability of x greater than or equal to 1 should be greater than 0.9 over here. Probability of x greater than or equal to 1 is actually 1 minus probability of x less than 1, and that is greater than 0.9. So now 1 minus probability of x is equal to 0 is greater than 0.9. So now if we use the formula, so 1 minus NC0, so 0.08 to the power 0 and 0.92 to the power of n is greater than 0.9. So here this will be equal to 1 and this is also equal to 1 because NC0 is 1 and 0.08 to the power of 0, any number to the power 0 is 1. So we'll get 1 minus 0.92 to the power of n, and that is greater than 0.9. So we can rearrange it. So 1 minus 0.92 9 is greater than 0.92 to the power of n, and this means 0.92 to the power of n is less than 0.1. Okay, right now here from, because AS level students, they don't learn logarithms in pure one. So A level students knows logarithm. So if you apply logs, so you can solve with that, or other way around, we can use hit and trial method. So I'll do both of them. So here, let's say if we are applying log into it, so then simply we will apply log on both sides. 0.92 to the power of n is less than ln of 0.1. So power will go in the beginning, so this will be ln of 0.92. So other side it will become ln of 0.1 over ln of 0.92. And if we solve this one using calculator, divide this by ln of 0.92. So this will be n is less than 27.615, like this. And other way around, if we use hit and trial method, although over here the hit and trial method, so because you learned this in IGCSE2, so 0.9 to the power of n is less than 0.1. So this is the thing. Now what we wish to do over here, because hit and trial, the meaning of hit and trial over here, so we need to make the base same on the both sides. So here on this side we have 0.92 to the power n, but here we are looking for 0.92 to the power something should make 0.1. So now for this one, you can type in your calculator 0.92 and you can try different numbers in it. Let's say if we take the power 10, so we will get 0.434, so which is more than that because we just look for 0.1. So let's try with the different value. Let's say make it 20. So once I put 20 over here to the power of 20, so I get 0.188. So I'm going more closer, so that means I have to raise the power for this. So then I can go for more close. Let's say I can go for 25, so which is 0.12436. Still we're going more closer, so let's say we are trying with 27. So 27 is 0.105, something like this. So exactly if you look into this one, so here we get 27.6. So you can try a little more. So 27 point, let's say 6. So it will give you 0.100. So that means 0.9 to the power of 27.6. So this is equal to 0.1. So now the bases are same. So that means we drop the bases and we compare the power. So n is less than 27.6. Since it says find the smallest possible value of n. So if n is less than 27.6, so that means n must be 28. So here A level students can use this logarithms and the AS students can use hit and trial method to come up with their answer. Hope this is clear to you. Thanks for watching.